Alrighty, so this is going on radicals, how to simplify radicals. And these ones obviously have a little bit more going on with them. So as we look at this first one, the very first thing we hopefully notice is that the index is odd and there's a negative on the inside. That negative could really be broken down into -1 times +1, and we know +1 can really be broken down into -1, -1. So we have three -1s, so we bring that negative out to the front. Now, that probably wasn't most people's first instinct here, and that's okay. Honestly, I don't do that every time. I simply notice that there is a negative and my index is odd. If that's the case, immediately bring that negative out to the front. Now, I can deal with my 135. So we need a prime factoring, which means break it down as much as you can. Because it ends in a 5 and a 5 goes into it, I can do some division and find out that it goes into it 27 times. 5 doesn't break down any further, but 27 breaks down to 3 and 9, and 9 breaks down to 3 and 3. So because once again my index is 3, I'm looking for a factor that shows up 3 times. So this could actually be written as 3 times 3 times 3 times 5. So you can see that I have that 3 times. So it's going to come to the front. And once again, that's because this is really 3 cubed. And so the cube root of the cube undoes it. It just becomes 3 in the front. Our 5 here, he has a little bit of a problem. He doesn't have a buddy. He doesn't have his two partners. So he has to stay inside of the radical. Now we looked at when we were dealing with variables with an exponent, we looked at this idea that we can actually divide the power by the index. So this is really k 28 divided by 3. If I do that division really quickly, and it's 9 with a remainder of 1. What that means is that that k to the ninth is able to come outside. When we divide it, when we reduce it, that k to the ninth is able to come outside. This remainder 1 tells me that 1k stays inside. We can do the same thing with our m's. This is really m to the 100 divided by 3. If I do that 3 into 100, we get 33 with a remainder of 1. What that means is that m to the 33 goes on the outside. This remainder 1 tells me that I have 1 m that stays inside. So the tricky thing here was just some big numbers on our powers, and then also this negative inside an odd index. So here's our final answer. Moving over to this one. The first thing I want to check, as always, is my index. Nothing is here, so I know that's really a 2. So I'm going to be looking for things that show up twice. So just as always, I'm going to start with my numbers. I know this immediately breaks down to 18 and 10. 18 I can break down to 9 and 2. 2's done. 9 is 3 and 3. 10 I can break down into 2 and 5. So I'd rewrite this as 2 times 2 times 3 times 3 times 5. Because it's a square root, once again, I'm looking for factors that show twice. So I have 2 2's, which would also be 2 squared, which is why I bring a 2 to the front. I have 2 3's, which would also be 3 squared, which is why I bring a 3 to the front. 5 doesn't have a buddy. He goes inside the house. Here, I have x to the 5th, so we're going to do that same idea. This becomes x to the 5 over 2. If I do 2 into 5, it's twice, so we're going to do x squared on the outside. Remainder 1 says 1, x goes on the inside. Now when I get here, x plus 3 squared. Well, many people are going to be like, I don't know what to do with that. That just looks so scary. But notice it still has an exponent on a quantity. So we can do the same idea that we've been doing with our variables. This is really just x plus 3 to the 2 divided by 2, so the power over the index. Well, that reduces down to 1, so it's simply x plus 3 to the 1, so it goes on the outside. No remainder. So our final answer for this one then would be 6x squared times x plus 3 times the square root of 5x. All right, let's look at our last one here. Check that index. I'm looking for things that show up 5 times. So 32, I can break down immediately into, that's a good question, 8 and 4. The 4 breaks down to 2 and 2. The 8 breaks down into 2 times 2 times 2. So I want to see, do I have 2 5 times? Will I have it 1, 2, 3, 4, 5? I do actually have it 5 times. So I can circle all of that. I could write this 2 to the 5th. So the 2 is going to come out to the front. Now I can do my variables. So it's going to be p 12 over 5. If I do 5 into 12, it's 2 remainder 2. So I'm going to have p squared because it goes in twice. And then inside of my radical, in my radicand, I have remainder 2. So that means I need to have p squared inside as well. G becomes to the 200 divided by 5. So I do 5 into 200. If you don't know that one, we can do it out. 5 into 20 is 4. And then we do the 0 to catch the zeros up. So it would be 40. That means we're going to have G to the 40 on the outside. And our last one then is 82. So we would do T to the 82 divided by 5. 5 into 82. 5 goes into 8 once. It goes into 30 6 times with a remainder of 2. So that means the 16 is how many go on the outside. So T to the 16. The remainder 2 says that we have 2 left over inside. Final answer, 2 p squared, g to the 40th, t to the 16th, that's a 16, the 5th root of p squared, t squared. So there you have it. Even though the problems get a little bit more complex, it's the same idea over and over. Prime factor your number, and then do your power divided by your index to figure out what goes on the outside. So the whole number, the quotient, is the exponent on the outside. Your remainder, what's left over, still stays inside of the radical.